Welcome, developers. So here is part 13, and we're going to talk about this new communications API that has been added recently to the Microsoft Flight Simulator 2024 SDK. And if you go and look into the documentation, you will see that there will also be reference to CommBusEvents. And of course, that comes from communication bus events, so events on a communications bus. I actually wanted to have fully working demos. Unfortunately, one of my demos currently is not working. It might work for you, actually. That depends a bit on how up-to-date you are with the releases. Because for me, I had the demo working and then there came a release, and with the latest version, it stopped working. And I'm currently in discussion with Asobo about it. And they said, hey, but it works here. And then I found out that actually he's one version ahead of me. So there is something there, and it could be something in my code. It could be a difference, a small difference in 188 versus 189. We'll see. But let's start anyway. So this is all about how to communicate and how to communicate between different applications that all of them are working within or without of Microsoft Flight Simulator, because we've got lots and lots of options there. We could have a WASM module, which is compiled from C or C++. We're using the WASM API. We could have electronic flight bag applications in JavaScript. We could have menus and dialogues in JavaScript, or even aircraft gauges either in WASM or JavaScript. And then we might have either a WASM or an external application using the SimConnect API. So if you have some of these or a mix of these and you want to provide a way to communicate between all of them, how can you do that? Because of course, it's not just about communicating with your other modules, it's also allowing communication towards other people's software. So let's start with the oldest alternative that we have. And I call that somewhat cheating, because L-Vars weren't really made for this, although they did end up being used for it. So what do? You have an aircraft and it's a sim object, and then you add custom data to it. And then you set data on that sim object. You make sure that the object has an L-Var, so a local variable associated with it. And then other parts of your application or external applications can pull or request the data where needed, and then they can get that data. So this gives you a lot of freedom. You can define variables as needed, but it's not all sunshine, because you need to go through the user's sim object. And that means there has to be an aircraft that you can connect to or connect your variable to. And there is, of course, no real notify at change. There is only polling, and polling here is meant in the software development sense of the word, meaning you check whether or not there is data or changed data. And of course, with SimObject variables, you can get something like send it to me every frame and only send it when data has changed. So that kind of gives you an on-set alternative, but it's still some kind of polling, because it's still up to you to check whether or not actually your data changed. Now, there is a better way, but unfortunately, this leaves out a JavaScript API, and that's ClientData. So you define your ClientData block, you set data when you want to send it, and you can request it when sent, which means that you get it as kind of a signal that somebody set the data, so there must be something there for you. Big advantage, we no longer are dependent on having a sim object that is coupled to this particular client data, but it is limited in the types supported by the API, and we've seen that when we discussed client data. But the biggest problem is there is no JavaScript API for it. And that is what this new communications bus is all about. You can send data, but now it's always formatted as textual data, and it becomes a so-called named event. So it becomes an event with a name. You subscribe to named events where needed, and that gives you the data only when it is sent. It has more advantages because now we have APIs on all platforms. So that means all different parts of our application or add-on can use it. And it's a real event API. It's not on set, and you still have to kind of check whether or not it's data for you because it might be shared by multiple recipients. We now link it to an event, and we say, I'm going to send this event. So I'm going to attach some value to that thing that happened. This is still new. It might still need some rework. In fact, there is a bit of rework already identified. There is a library there that is very fast and compact, but unfortunately a bit old, but still it's there. And it's a default JSON library because that allows you to send all kind of formatted textual data. So let's start with those CommBus events. Messages now have an event name, and you subscribe to events by name. Senders can choose which platform API gets the event. So actually, this also allows you to say, I only want to send this to other JavaScript add-ons, or only to WASM, or only to SimConnect, or even only to myself. And it is defined as bits in a bit field, so you can make a combination of it. The default actually is set to be all but self. That sounds pretty obvious, but it might be that you have a big application and that you want to say, well, there are other parts of my application that are also listening to this event, and I want them to receive it as well. But the default is all but self. When you're subscribing, actually what is done is that an ID is mapped to the name, and the message will then contain that ID instead of the name. The obvious reason for that is that an ID tends to be smaller than the name, so it lets you use long and descriptive names for the name, because not every event will get that entire name sent along, but it will be an ID, and it's the usual client ID, so it's local to your client code. And the message then contains that ID. So when you get a message, you can dispatch depending on that ID. And yes, there was this mention of JSON. Now, this might be obvious to some, especially some of the younger developers, but for people who have always been working with sim object data or client data, then this is something to get used to. The message contains a string as payload. Of course, we usually have a limit on the size of messages that are being transferred. So if the payload is large, you will get it in chunks, in blocks. And there is a DW entry number and a DW out of field that we've seen before. And you will get multiple messages, so you need to collect those into one entire message before you start parsing that string. The API probably started in JavaScript because JSON, the J of JSON, is JavaScript. It's the JavaScript standard object notation, and it's a standard exchange format used in web applications. And since with Microsoft Flight Simulator 2020 and 2024, we have a much larger use of JSON and HTML, this is, of course, become a standard way of doing it. It's very flexible in the payload, but of course the difference now is, instead, as with data blocks that you could define for sim objects or for client data, there is no guarantee on the structure. You always have to parse that JSON structure and extract the fields that are important for you. A version of a library called RapidJSON is bundled with the WASM API. So also for external applications, it is available in the SDK and you can use it. It is a choice. It is pretty old code, latest release in 2016, and the last update on the library itself was 1 year ago, which is already some time ago. And actually, what has been added at that moment is not in the release. So what is bundled is actually a copy of that latest release. If you want to look at alternatives, there is luckily quite a lot that you can choose from. As said, RapidJSON, it uses C++03, so it is pretty dated, but it's very fast, very compact, and it doesn't use exceptions, which some people prefer. But it's an old API, and yes, I tend to call it unmaintained because of the age of the last updates. There is a much more popular one on a GitHub repository from a user, N. Lohman, and it's using C++11. It is very nice, very ergonomic. I've called it that. It is very often used, and it gives you lots of modern things you can do with it. You can even write pieces of JSON in your code easily, even though it's a C++ application. But of course, that means it is slower and heavier. It's a larger library, and it has to take into account more. Now, for most people, that actually won't matter because you don't use it that often. If you're going to use it for events that you want to send, say, every frame, then probably it's not for you. Also, it does throw, so that's something you need to take into account. Then, of course, there is BoostJSON. Boost has everything, including the kitchen sink. It's C++11 and at some parts even more recent. It's allocator aware, it's well maintained, but it's a Boost dependency, and that is something you need to accept. I sometimes compared it with the world of Java, where there is the Spring and Spring Boot library, which tends to favor its own implementations, even for things that might already be adopted in the more common standards. So this is the same for Boost. Boost is very opinionated, saying our versions are better and faster than sometimes what is available in the C++ standard, or our version is running ahead, so you can either move to C++ 26 or use our version, and then you've got it with older versions of C compilers. But it does mean that you need to take along more of Boost than just the part that you want to use. Again, it's not necessarily a disadvantage because, yes, it is good. But once you start, you have to go and add more than you originally intended. So it's something that you need to take into account. Then there is SimJSON, and that is a very fast parser that tries to use as much as possible of your hardware as possible. And it's using a very recent version of C++, but it's read-only, and writing is less common. So it's mostly for receiving. not for sending JSON. Then there is the Glaze library, uses C++20. It even allows for bits of reflection, so it makes it very easy to define your own classes, structs or classes, and then without using macros, then build JSON from that. But it's very young and not that common. So in that sense, you might also consider it unproven. So take a look. Maybe you like it. It's very modern. It offers a lot, but it's something, again, you need to consciously adopt. Then there is JSON Cons. It uses C++11 and 17. It has very rich features and a nice API, but again, it is slower than RapidJSON. So there are a lot of alternatives to the RapidJSON. RapidJSON is clearly intended for the WASM crowd and people who want to have very high frequency flow of messages. Take a look. So what does this mean? Well, this API exists, of course, for the JavaScript integration. JSON was an obvious choice there, and that's how we got it. Then RapidJSON works, but if you keep it simple, you might actually just use regex. It depends on how complex your structure is. 2 points. If your data structure is complex, it uses nested objects, it uses arrays, I think the best way to go is to use a real JSON parser, even RapidJSON, but don't try to do that with regex. I mean, yes, probably you're smart enough and you can do that, but why depend that you can build yourself what somebody already spent a few years in building and perfecting? If your speed memory requirements aren't tight, then yeah, I think you'd better look for a more modern library than RapidJSON, even if only because it seems to be rather unsupported at the moment. So actually, that's all there is that we can tell about this without going to the first demos. So let's start with a demo, a pair of demos that uses the C API of SimConnect. Okay, so here we are in Visual Studio, and you see it's the common standard template that I've been using for my demo programs. So it connects, then handles messages and disconnects, because this is the caller. And handling messages is just the usual while here, where it waits for a timeout and then empties the queue of messages. It's just looking for exceptions, the open and the quit messages. And then every now and then it will broadcast a message. And this it does through the broadcast function, which we have here. And what it does, it takes the message and then sends that using call CommBusEvent, using a event number, name, and then the flags where it uses default, and default in this case is to everything but self, and then the buffer with the buffer size. And of course, it will complain if that failed and then returns. So it will do this for a number of times. And then we have a second program that actually listens to these. It starts the same, but it subscribes to those messages, then handles messages, and then unsubscribes and disconnects. Handling messages is almost the same, only now we take the receive ID CommBus messages into account, and then go to handle CommBus. and handle CommBus checks whether it's our message, event hello, and then prints it out. And what is this event hello? That is our local client event ID that was introduced when we subscribed here with subscribed to CommBus event, where you give your client ID and the name of the event. So just as with the normal regular events, we are now looking at events by ID, and those IDs are local. So if I have multiple listener applications, they can have different ID values, but the subscribe takes care of mapping that number for that particular client to the name of the event. So let's go to the caller application and we'll start it. And it will start broadcasting hello world. We go here and we start the listener. And you see we missed 6, but starting from number 7, we are receiving the messages, then up to number 10, and then it stops because the sender did it 10 times and then quit. So this is pretty simple how that works. And of course, this is now one program sending and the other listening. So of course, I made ping pong also in a version for this. So let's switch to that one. And go here to the CommBus ping pong. Select debug 2024 and we'll build that. And well, this looks very much like our earlier ping pong using ClientData. Let's just skip here the standard stuff and go, and we've got a subscribe and a unsubscribe. The subscribe is now only subscribing to pong messages because ping is only interested in sending pings and receiving pongs. And here you see it sending a ping. And here we have handle messages where it checks for CommBus messages and then checks whether it's event pong and then says that we received that. So this works just like the previous one. I mean, I can show you pong, but I suppose you can figure out how that works. Let's go and move over to that one. Let's start the passive one, pong. It's now waiting for the first ping and start ping. And you see that it works, ping-ponging happily away. And pong is still waiting for any further pings, but just like before, we stopped that. So that is a very simple demo, just using SimConnect to use the CommBus events. Okay, so we're back and let's continue. So some remarks here. It uses a client event ID, and if you look in the SimConnect header and the documentation, you will see that it actually is using the type SimConnect client event ID, but it is not a real event ID yet. It's a new API, and it's quite likely that this will change and become its own type, because I actually did a small test registering and mapping a client event ID on a normal event and then checking whether or not that would clash with a CommBus client event ID, and it didn't. And if you first do the subscribe to CommBus event and map a client event ID there, then you can still use that same event ID value for your regular events. So it's not the same data space, the same type, and SimConnect will not detect that you're reusing that ID. Be careful. It's still the same type, but I've already had the reply that it might change. So then, of course, the nicer demo, and that is JavaScript. Let's go and have a look. Okay, so we're back in Visual Studio, and now let's start with CommBus 2 EFB. And this demo, it comprises of two programs. One of them is a C++ program using my C++ library and sending CommBus events from there. And then there is a second piece, which is an actual piece of JavaScript and HTML and some styles for use in the electronic flight bag in your aircraft. And it will show messages coming in. So what I can show you here is just this part. And let's go down. There are the usual standard functions. And we have a test. Now you immediately see that it looks a bit different than the previous one. This one is using the C++ library. And what it does, it uses a new CommBus handler that has been introduced. And CommBus handler allows you to send the event with the name of the event and then the message. And of course, for the message, it uses a string view as well as for the event name. So that is all what you see here. So it's a very simple program. It sends a message and then handles any potential exceptions coming in, and then it quits. So we can build that, and I probably should first have made sure that we select the 2024 SDK. Okay. And now let's go to the flight simulator. Let me switch here. Okay, so flight simulator is running, and we're just going to use a DA62. We're going to put it on my favorite airport on a parking slot and start the flight. At the same time, we still have this, so let's go. Okay, so we have our sender. First, of course, we need to make sure that we have the add-on. So I need to go here, open a project, then off screen, I'm going to navigate to that project in the build tree and open that project. Then we get this and we say build all. Of course, if you have a add-on on the marketplace, then that's no longer needed, but this is for local development. And then we go to ready to fly. We'll skip into the cockpit. And now if we go and take a look at this, and there is our CommBus add-on here, this one. Now, like that. That wasn't really readable before. Here, you can see we have our CommBus message viewer. Okay, let's go here and we run the sender and say, hello world. And you see our message was transferred and received in JavaScript. Now, this is a very simple demo, but I think it shows the power of this new communications bus that allows all the different language platforms to communicate to each other. Now, I'd like to also show you my other demo, but, well, just to show you what my problem is, if I open it here, okay, so I've now loaded the other demo, and you see if I open it up, all I'm getting here in this top left corner is just this piece grayed out. This should have been a small window that then allows me to send a message on this side. So unfortunately, that's not working, and I'm still talking to Asobo about that, and we'll be back with updates as soon as it's working. Okay, so that's just another lesson in never assume that a demo is going to work and that it goes smoothly, because you will forget stuff. Okay, let's go and move on with the presentation. So just to be sure, I am not an experienced JavaScript, TypeScript developer. I've done most of my professional work in Java. JavaScript is completely different. It has changed a lot over the past 10 to 15 years. Adding TypeScript was a good step forward, but still there's a lot there happening, and especially there's a lot of choice. So you're very dependent on what your platform and SDK builder will give to you. In this case, that means the SDK for Microsoft Flight Simulator. And unfortunately, the documentation on especially how to hang dialogue under the menu is simply not up to the level that I can take it in and use it. What I actually did was cheat a bit, because I used Claude Code. And Claude had difficulty finding good examples. That means it took several iterations and where I had to give it screenshots of what was happening, and it said, okay, so maybe this would be good, and then it would try something else. And I simply didn't know, because there was no documentation and no example. I mean, there is an EFB example, and there are JavaScript gauge examples, but not for the dialogues. So we cheated a bit and used some examples from existing add-ons. I didn't copy verbatim code from there. I just told it, well, it looks like they are doing this. And then he would say, oh, is that how it works? And then try something similar. But at a certain moment, we had something that worked. And then we got an update on the Flight Simulator development channel. And since then, it stopped working. So, yeah. I've talked to Asobo for help on the developer support website. They say my project works, but they are running it on MSFS version 1.8.9. I found out that actually if you don't run it full screen but in windowed mode, the version is showing in the title bar. That was new for me. I have still 8.8.8 and they have 8.8.9. And it could be that that is the difference. It could be something else. JavaScript is a bit more unpredictable. Languages like Java and such, if you add changed libraries in the runtime or add new libraries in the runtime, that tends to not change behavior of the application. It rather will bomb out and saying, you've given me a wrong version, so I cannot use this. Rebuild, please. JavaScript just happily uses whatever is there. So if you have a version that is different, then it will happily use that different version and you won't find out until it tries to use it. It doesn't have a strict type system as a language like C++ nowadays has and Java and C# are using. They will say either we know for sure at compile time this work, or they will add in runtime code that makes sure that at runtime the check is made. JavaScript just says, you're calling this method on an object. It happens to have a method with that name, so I'm calling it. I don't know if it's what you expect. I don't know if the parameter list is the same, but I'm calling it anyway. And that is a big difference. So, yeah, if this sounds like I'm a bit frustrated, well, forget it. I know JavaScript long enough to know that this is the way it works. So, in practice, what you do is you have automated build environments and you test and test and test and test. And you will test your code against different versions of your target platform. And I simply am not set up for running different versions of Microsoft Flight Simulator other than just having one MSFS 2020 instance and one 2024 instance, and I don't have 5 PCs with 5 different versions of each. So I'm sorry, I have to do it like this. Let's continue. So, wrap up. The CommBusEvents are a very nice addition. I like them a lot. They give you full support for JavaScript, and even though I had some problems, I was kind of surprised how easy it turned out to be. There is a lot that you need to learn about the libraries that they provide and the standard style sheets that you have to use. But if you are an experienced JavaScript and web developer, then there shouldn't be anything to surprise you. So this is very nice. And of course, it will end up as WASM code, so it will be pretty performant. It just is not always guaranteed as much as you'd expect with C and C++. The event style is simple, and that is something that I very much like. Also, I'm used from the Java environment and my work there. I'm used with having JSON messages flying around and using strings for names of events. That tends to be less of an issue if you are in an enterprise environment. If you're working in an environment where every frame counts and frames are counted in milliseconds, then it might be. It's a new API. So changes can and very probably will still happen. And especially the type client event ID is a major candidate there. I would have liked a more modern JSON library, but that's because I'm not running add-ons that are dependent on very frequent messages. So I understand the reason for it. If you have very simple messages with just a few fields and you are creating those messages yourselves, seriously consider just using regex, because it will be even faster than using RapidJSON. The only real worry I have with RapidJSON is the age and the relative quiet on GitHub around it. So that's the end of this presentation. I think next time we'll go and take a look at input events, because there are some things there that we haven't done yet. And I've been doing some experimenting, maybe something like writing a program that reads a controller, then subscribe to events from those controllers, and then use those to send actual flight simulator events. I mean, of course, it's done. There are a lot of programs like that, but I think the enumerate controller and enumerate events API calls are very interesting for these kind of situations. I might also take a look if it takes into account which actual aircraft you have selected. So it's very likely, at least I hope it is, that you will get different lists of the events depending on which aircraft you have loaded, which makes these kind of add-ons a lot more interesting to build. So we'll do that next time. And as usual, I do this for the subs and likes. So if you feel like giving me one of these, please do. And I'll see you in the next one.